Welcome to the second part of the LangWatch Optimization Studio tutorial series, and this time we're going to focus on our entry node and datasets. Datasets are at the heart of the Optimization Studio because we realize that the only way to actually work with something non-deterministic such as LLMs is by bringing it a lot of data and running it across lots of examples. One example won't give you the confidence that the thing is working well, but 800 examples, if you get good results on that, then yeah, it's a pretty good indication. Now, you don't need to have 800 examples to get started with the Optimization Studio and run optimizations and so on. Just so you have an idea, 20 examples is already enough for you to start getting some good results from the DSPy optimizers and improve your prompt and demonstrations and so on. This is because it also uses LLMs on top, which are pretty smart. So if you don't have a dataset yet, you can start building it right away. Let me show you how. By clicking this edit button, you open up the dataset and you can start making changes here right away. You can see this as your little Excel spreadsheet and you can start adding data here already or somebody else from your team. You can change this dataset however you like to add more columns for more information. For example, I can add a new comments field. And then someone from the team can add comments here to helpfully help the LLM make decisions. Notice that when I add a new field, it immediately shows up here on my node, and I can use it back to one of my other nodes. Okay, going back, you can view your other data sets over here, where you get the full list. And if you don't have any data, you can create a brand new one here. This will give you a simple hello world. You can edit the columns and you can build data set however you like. Add new records, delete, and so on. However, if you already have some data hanging around, whether you build it through Excel or extracting from your current system with pandas, you can just upload the CSV here. I'm going to upload the Hotpot QA dataset, which is a dataset about RAG questions that can be answered with Wikipedia articles. Again, I can add new columns if I want, like human checked, and I can change the type of the variable to match the expected format or whatever I got from my CSV. Then as I hit save, my dataset's over here. I can edit, and I can click select dataset, updating my current node to be used. Now let's undo this since our pipeline already works well with the other dataset. Let's keep the transactions one. But what I want to show you is this field, the manual test entry. This is the field that controls which entry is going to be picked up when you do a manual execution. By default, it is random, so then every time you execute, it chooses a new entry to pass through, and then you can see the results. If you want something more stable, you can just choose the first entry here, and this is the one that will always be passed through when we're running just a manual execution. There you go. But another very important thing on datasets is how we split them. By default, we have an 80-20% split. What does that even mean? Well, the Optimization Studio is all about optimizing your LLMs. And to optimize your LLMs, we show it the dataset as some examples that you can learn from. However, if you're training someone for a test, you don't want to give them the final test results, otherwise they can just cheat, right? So what we do is giving a lot of data to study, but save a part aside so we know that it learned well and it's not just memorizing the answer and it didn't overfeed to the data. So we name this split optimization set and test set. By default, it's an 80-20% split, which means that we're at around 160 entries for the test set. But we can also change to hard code the number of entries to get started with a smaller number. That will be faster for us to iterate, and then later you can give it a higher number of examples. And then the other important part is the shuffle seed. So to prevent your dataset from being biased, for example, if it's organized in a certain order, like alphabetical order, or if you have all your classes like class A, then class B, then class C, if we just split it this way, this could be a problem because, for example, if we took the first 80% and they are all class A and B for optimization, and then on the test, we get the last 20%, which is only class C, then the optimization pipeline wouldn't learn anything about class C and it will fail completely on the test set. To avoid that, we shuffle it. However, we don't want to shuffle it every time because if the quality changes, we want to know whether it was from a change we made or it was just because the dataset shuffle around. So 42 here is going to mix up your dataset, but always mix it up on the very same way. If you want to see if your pipeline is resilient to shufflings, you can change this number 42 to 41 to whatever number. This is just a C to keep it stable. Now we're going to focus more on evaluations in one of the next videos. So let me show you already a sneak peek of it so you understand what I'm talking about on this optimization test split without any quality measurements at this point. So you can just hit the button evaluate here, and then first of all it's going to ask what change do you make. This is just so after you run many evaluations you can see what changed from version to the next. In this case we added the comment fields even though we're not really using it, and then here you can choose on what data you want to run your evaluation on. You can run on the test entries, which is the default behavior, the 20 entries that we selected here, or you can also run on the full 800 entries data set, or even the train one. Then, because we're running a whole lot of examples, another thing that you have to do is add your own API keys. So let me add mine really quick here. I'll hit save, and then we're ready to go. Then on this evaluations panel that pop up, you can see that we went over all the 20 entries on the test set, and you can see the average cost and the average duration, as well as how much this experiment cost in total and the runtime. This gives you a pretty good idea already on how much your pipeline costs and how long it takes to run. However, what we really want to measure here is quality, right? So stay tuned for the next video where we are going to talk about evaluators.